Welcome back to my class. This is risk return in the capital asset pricing model lecture series part 2. Okay, so in this lecture today, we're going to be talking about portfolio diversification and risk, the capital asset pricing model. I'll show you how to estimate beta using CAPM. We'll be computing the required rate of return using CAPM. We're going to be talking about security market line, SML, and we're going to be talking about the market equilibrium. So after watching this lecture video, you'll understand the main concept of the capital asset pricing model. Describe what the capital asset pricing model is and illustrate how it can be used to estimate a stock's required rate of return. Estimate beta using formula in Excel. Compute required rate of return of a stock or a portfolio using the CAPM. Understand the trade-off between risk and return. Able to draw the security market line and use the CAPM to find undervalued and overvalued securities. So these are the main learning objectives. So from our previous class, you know that you can eliminate non-systematic risk by creating a portfolio. So diversification can substantially reduce the risk without an equivalent reduction in expected returns. So you can reduce risk significantly without reducing expected return. Okay, but you cannot eliminate market risk. You can eliminate only non-systematic risk. You cannot eliminate systematic risk. So basically, the total return equals to systematic risk and unsystematic risk. And by diversification, you eliminate most of these unsystematic risk. Okay, so in modern portfolio theory, we use standard deviation as a total measure of risk. Okay, since we have only one risk, systematic risk is left if we have a diversified portfolio. Unsystematic risk is diversified away or it's eliminated. Okay, so investors, they have to take the systematic risk. They can eliminate the unsystematic risk having a portfolio. Therefore, the market rewards investor for bearing only systematic risk. Okay, so unsystematic risk is not relevant because it is diversified away. Therefore, as a result of diversification, an asset's expected return depends only on its systematic risk. Okay, so basically, when you have a well diversified portfolio, basically you have a portfolio like a market portfolio. Okay, therefore, your expected return is going to be your return on your portfolio, and your risk is going to be the variance in the market if you have well diversified portfolio. So if you are holding a market portfolio, You have only market risk left, which is systematic risk left. The unique risk is eliminated. Therefore, investors should be rewarded only for taking this market risk because it cannot be diversified away. Okay, so we cannot use standard deviation as a measure of risk. Modern portfolio theory, Markowitz uses standard deviation to measure risk on a diversified portfolio. Okay, they agree that investors they can eliminate unsystematic risk and only market risk is going to be left over if they have well diversified portfolio. That's the finding of modern portfolio theory. Okay, in CAPM, the capital asset pricing model, actually using the same concept, explains the relationship between risk and return, but the measure of risk in CAPM is beta. Since unique risk is diversified away, standard deviation is not relevant. It's not true measure of risk. Okay, so we're going to be using beta as a measure of risk in CAPM. Okay, so basically your unsystematic risk is gone and only systematic risk is left over. So CAPM uses beta to estimate systematic risk. All right, and beta you can compute as covariance of stock return, which is part of your portfolio, covariance of your stock return with the market divided by variance of the market. That's going to be your covariance. That's going to be your beta. Okay, so beta is the measure of risk, measure of portfolio risk, measure of systematic risk. So modern portfolio theory shows that firm specific risk can be eliminated through diversification. So CAPM use the same theory. Firm specific risk is eliminated. So only left is systematic risk. So a fundamental question in finance is how the risk of an investment should affect the expected return. Okay, so how should the risk affect expected return? The capital asset pricing model, the CAPM, provided the first coherent framework for answering this question. CAPM was developed by Sharp in 1964 and other people, Jenner, Rickner, and Morse in 1966. These other people also contributed in the development of this theory. The CAPM is based on the idea that not all risks should affect asset prices. So only systematic risk is relevant. So the risk which can be diversified away is not relevant because investors they can eliminate that risk. So CAPM gives us insight about what kind of risk is related to return. So basically CAPM used the same model portfolio theory concept, okay, because systematic risk is the only risk we should consider when we are talking about return. So if an if an investor hold a security, a risky security, the investor should receive premium for bearing that risky asset. Okay, and beta is a measure of risk. So required rate of return on an individual security should be equal to, so your required rate of return should be equal to risk-free rate plus risk premium. Okay, so here we have market risk premium. RM minus RF is market risk premium. You multiply with beta, that's gonna give you risk premium for holding that security, which is risky. Okay, so we can use beta to estimate the risk of a security, which is the part of the well diversified portfolio. Okay, so the implication of CAPM is that returns increase with relevant risk, and there is a linear relationship between risk and return, and non-systematic risk is not relevant. Okay, so the CAPM gives a new insight. Beta is the measure of risk. That is the main contribution of the CAPM, the capital asset pricing model. Because modern portfolio theory already finds that when investors they hold a well-diversified portfolio, unsystematic risk is eliminated. So only left over is systematic risk. Okay, so modern portfolio theory still uses standard deviation to measure risk, and SAR came up with new idea that, well, if investors they hold a well-diversified portfolio, then non-systematic risk is eliminated. Therefore, we have only systematic risk is left over. So they introduced beta, concept of beta. Beta can be used to measure the risk of a security, which is the part of the portfolio. Okay, so that is the main contribution of CAPM. CAPM has several assumptions. So investors they choose their portfolios based on expected return and variance. Investors they have identical subjective estimates of means and variance and covariance of all assets. So investors trade in perfect capital market, which means there are no frictions such as taxes, transaction cost, restrictions on short sales. There is no differential between borrowing and lending rates. All assets are perfectly divisible. Investors are price takers and they do not try to influence prices. And the supply of all assets is given. So those are the assumptions of CAPM, and some of them are not realistic. Okay, but the main innovation of CAPM is how to measure risk of a individual asset, which is the part of the portfolio. Okay, so according to CAPM, required rate of return on a security is the function of beta. Okay, so there is a linear relationship between beta and required rate of return on a security. Okay, so basically here this CAPM equation has couple of things here. So risk-free rate, which is pure time value of money, so we measure by risk-free rate. Amount of systematic risk is measured by beta, and reward for bearing systematic risk is measured by market risk premium. Okay, so Investors, they hold well diversified portfolio which is similar to market portfolio. Okay, so since all the unsystematic part of risk is eliminated, only left over is systematic risk. Okay, so beta captures that systematic risk, which is the basically sensitivity of stock return with the market is captured by beta. So beta is the measure of risk. Okay, so there should be a linear relationship between required rate of return on a security and beta. So that is the CAPM. Okay, and how to estimate beta? So beta coefficient measures the sensitivity of stock return with the market return. Okay, so basically you can estimate beta using this formula. This one is covariance of stock return of the market divided by the variance of the market, or correlation between the stock return and the market return, standard deviation of the stock return, and then standard deviation of the market return divided by variance of the market. Okay, so you can use this formula to estimate beta. So beta, the value of beta, if beta equals to 1, then the risk on the security is similar to the market. So if beta equals to 1, then the security is as risky as market. If beta is less than 1, that means the security is less riskier than the market. If beta equals to greater than 1, then the security is more riskier than the market. Okay, so you can, so basically we can use regression. Okay, so this is a market model. So here is your rate of return, required rate of return equals to, this is the function of beta if you use market model. Okay, so we're going to be using CAPM to estimate beta, which is a little bit different, and I'm going to show you how to estimate beta. So basically beta is the slope of this regression line. Okay, so this is just the slope of this regression line. We can use formula to estimate beta. We can use Excel slope function, and we can estimate beta using linear regression. Okay, so basically let's go back and look the CAPM equation. So we need to estimate beta. This one here is X. Okay, market risk premium is X, and if you take this one other side here, we can rewrite this equation as Ri minus Rf. So Ri, which is required rate of return on a security, minus Rf equals to beta times market risk premium. So we can rewrite this equation. Okay, so let's use Excel. Okay, because formula, you need to compute several information here. In easiest way to compute beta is using Excel or using Excel linear regression function. Okay, and basically it's a simple linear regression from statistics 101. Y equals to intercept plus beta times x variable plus absolute. Okay, which means this one should be equal to 0. This is intercept, So we rewrite CAPM equation to make similar to this simple linear regression. Okay, and here in this regression, this should be equal to 0. This alpha should be equal to 0. So let's use our Excel to estimate beta. And in my previous video clip, I showed you how to collect market data information, stock market pricing information for a security and on the market. So S&P 500 is the measure of market, and then these securities are individual securities. So we have here three securities. So we assume that we're going to be putting 1/3 of our investment on each of these securities. Okay, so these are the weights. We need those weights to find portfolio return and risk on a portfolio. Okay, so first of all, we have this pricing information. Okay, and I'm going to post this Excel uh, file for you to see what I did here, and I have explained everything here. So please look it carefully. So first thing you're going to be doing here is you find rate of return. Rate of return equals to price today, so P1, okay, minus P0 means previous day price, in this case previous month price, and you divide by P0, okay, so you get rate of return. Now in Excel, you can basically drag the formula and make sure you check it, okay, so everything good. Once you know that everything is good, you can basically drag this down, okay. I'm leaving this last row here blank because if you pull this one here down, we don't have this because we are using uh, the last data we have is January 2010, so we need December 2009 data. Okay, so I'm going to leave that last row blank. Okay, once you compute rate of return, now you can find portfolio return for each month. So basically, using the formula, weight of each securities times return on each securities, okay, add them together, so it's the weightage average. Okay, so I did that, and then I can drag the formula down here. Okay, so now each month I have this portfolio return. You can also use sum product function, which is sum of the product of each of these weight and the returner. Okay, you can use that function too, so it's up to you. Now how do you find average? Okay, finding average is very simple, equals to average and you're going to be doing this one, average, and close here. Okay, so you get this average. By the way, I think I was intended to talk about beta and end up doing something. All right, let's start doing beta. So I don't want to go over the whole thing here. I'm just using one security. Okay, this is here I'm using actually these three securities and the market, because you're going to be needing market information. So first thing you need to collect is stock pricing information. Okay, well, estimating beta. So as you know that Okay, so this is the Excel file I'm gonna, so well, this is the Excel file I'm gonna use to estimate beta. Okay, so I have stock price information, I have market pricing information, and I also have a risk-free return. Okay, and you know that returns are annualized. Okay, so first thing I'm gonna do is create my data, create my monthly return. So let me delete this one. Your return equals to P1 minus P0 divided by P0. Okay, you divide on the difference of P0 and you get rate of return. Once you compute rate of return for one security, you can just copy the formula and compute rate of return. Okay, and since these returns are monthly and our risk-free rate is annual, we need to convert our annual rate. Here I just use 1.56. Just assume that the rate of return was 1.56 on all this time period. So I'm just using for your project. I have instructed you to use risk-free return from Federal Reserve website. So please do that. So here, just let me convert that annual return to monthly return. So since we are using monthly data, we want to divide annual return by 12 months to make it monthly return. Okay, and I'm using the decimal format of this return, so I'm going to use decimal format for risk-free return too. And copy down, I have this risk-free return. Okay, now if you recall CAPM, this is the CAPM. So Ri minus Rf, that's going to be our y variable, and Rm minus Rf is going to be our x variable, and beta is the one we're going to be estimating. Okay, so you have to create the data set just like this. So we need these two numbers, Ri minus Rf and Rm minus Rf. Once you have that information, you can estimate beta. Okay, so let me estimate beta here. So first of all, I need to set up the data. So I want to find the rate of return on Apple minus Rf. So basically, this one here equals to Apple return minus monthly Rf. Okay, and I don't want this Rf keep on changing, so you can press F4, so you can put dollar sign so that it's gonna keep on staying same. Actually, you just want to control K, but you don't want to control number, because when you drag down, you want this keep on moving down, but when you want to drag this side, you want this still stays same. Okay, so let's use this one. So Apple return minus Rf. Now let's drag to all the way here. So as you can see that your Rf still is going to stay same. So let's check this one. Okay, let's check this one. That's good. And let's check Rm minus Rf. Good. Well, now let's copy the formula down here. And now we set up the data set. So basically, you are converting your data set in this format: Ri minus Rf, Rm minus Rf. Okay. So Rm minus Rf is your independent variable. Ri minus Rf is your dependent variable. Okay. Once you create the data set, then basically you can use slope function equals to slope parenthesis, and your y variable here is this one. So stock, individual stock return, and your x variable is market return. Okay, so your this one is market return. Close the parenthesis. Okay, so you got using slope function, you can get beta. Okay, that's the one way. But I want you to be able to estimate beta using regression. So let's use the regression. And where do you get the regression? You click in data and data here. If you don't have this data analysis here, please go to file and then option. Okay, and then click on add ins, double click, and then uh, go here, and please make sure you click this, check this analysis toolpack, and then do OK, and you will have this data analysis. Now let's estimate beta. So click on data analysis and find regression. So press R on your keyboard. Okay. Okay, now here you have to define your inputs, and you're going to be doing one at a time. Okay, so if you want to find out the beta for Apple, you're going to be selecting return on Apple minus RF, which is Ri minus RF. Okay, so that's your Y variable, and our X variable is market. So risk premium on the market, RM minus RF. That's very important. Okay, that's our X variable. Since I select this number with the heading with non-number, so we want to label, and then where do you want your output? Do you want your output right here in the same page, or you want in different places? You can define that. So let's click, I just want here, right here. So let's click on output range. So here be careful, because if you just click something here, somewhere here, this number is going to be changed. Okay, we don't want this number to be changed because that's the number we want uh, for our estimation. So make sure you click here before you do anything. Once you click here, you can define you want here, you want here, you want here. What do you want to keep your output? Okay, define that. Then click OK. There you go. So you have beta. This is the beta coefficient for Rm minus Rf. Okay, that means this is the beta of these securities, Apple. Okay, so basically let's look at the equation. This one is beta, Rm minus Rf. Okay, so we use Ri minus Rf is y variable, Rm minus Rf is x variable, and run the regression, and we got the beta. So this is the number we are going to be looking for. Okay, so this is the measure of risk. Beta is measure of risk in CAPM. Okay, so rate of return on any securities, required rate of return on any securities is the function of beta. This is how you're going to estimate beta, and hope this can help you to do your project. All right, so let's go back to our PowerPoint's presentation. So we estimate beta. Okay. So now the beta, basically if it equals to 1, then it is the securities is risky as market. If it is more than 1, the security is more riskier than the market, and if it's less than 1, it's less riskier than the market. Okay, so beta shows the risk. Beta is the measure of risk, measure of systematic risk. Okay, now how to compute your portfolio beta? What you can do here is portfolio beta is just weighted average of all the betas. Let's say you have security 1, 2, security n. So what you can do is weight up each securities on your portfolio times the beta of each securities. So you're going to use the similar analogy like computing portfolio return. Here we have portfolio beta. So the weighted average beta is portfolio beta. Okay, and how do you get weight? I already explained you how to get the weight. Okay, and we're going to do some problems. So let's consider this example. Okay, so this one has backend risk stock has beta equals to 1. Okay, and this one Baytown has beta equals to 0.4, and we have Candyland has beta equals to 2. Okay, so if you want to create a portfolio of Breckenridge and Baytown, and you're gonna just create weighted average of these two companies beta. Okay, so we're gonna be putting 40% on this Breckenridge, so we're gonna be putting 40%, because since you are putting 60% on Baytown, then you have 40% on this Breckenridge, right? So 40% times beta is 1.2 plus 60% on Baytown times beta equals 0.4. So if you do this math, you're going to have 0.72 beta. So that's the portfolio beta. Same thing for if you want to create a portfolio of Breckenridge and Candyland. So Breckenridge is going to have 40% investment, and the other one has 60% investment. So 40% times beta plus 60% times beta 2. So its portfolio beta is 1.68. Okay, so this is how we're going to be computing portfolio beta. So according to CAPM, a required rate of return on a security is the function of beta. So here let's estimate a required rate of return on this security. Actually, I should have just RI, because I don't want to keep this R bar, which is we use to denote expected return on a security in modern portfolio theory. So let's use this one right here, RI. Let's call RI is required rate of return. And we have these 4 securities. And as you can see that the beta is increasing. Okay. Everything else is same. We have risk-free rate is not going to be changing. The market return is not going to be changing. Only thing changing is beta. So according to CAPM, required rate of return is function of beta. Okay. Only thing we need to care is beta, because beta measures systematic risk. And a well-diversified portfolio has only systematic risk left. Okay. So investors should be rewarded just bearing that market risk. That's the whole point about CAPM. So let's find required rate of return on each of these securities. So let's put risk-free return. plus beta times RM minus RF. So RM minus RF is risk premium on the market. Okay, so beta times risk premium on the market plus RF is gonna give you required rate of return on these securities. Okay, so by doing this operation we have 9.4. So this is this KO security has 0.64 beta. So that means the required rate of return is on this security should be 9.94%. And now in this Intel, only thing changing is beta. So beta increased from 1.64 to 1.64. Now you see here required rate of return increased to 18.44%. Another company, this KEI, has 1.79 beta. So return should be 19.72. Everything else is same. And this other security has beta of 3.69. So the required rate of return on this security is 35.87. So the conclusion here is higher the risk, higher the return. Okay, and here the measure of risk is beta. In modern portfolio theory, we have measure of risk is standard deviation. Okay, in CAPM, measure of risk is beta. Only beta explain the return, nothing else. Okay, so as risk goes up, required rate of return also should go up. Okay, let's do another example here. Suppose we have risk-free return of 4.5% and we have market risk, return on a market portfolio is 13%. So if you create a portfolio of these securities, so you put 100,000 on security, this KO and the Intel, you put 150,000, you put 200,000 on this security here, and 250,000 on this security here. Okay, so what is your portfolio return? Okay, so first of all you need to find out the weight. Okay, so weight is basically your investment on this security, on each security, divided by total investment. So if you add all these numbers, you're gonna have $700,000, and to divide $100,000 by $700,000, you're gonna have 14.29%. So we got the weight of each of these securities. Okay, multiply weight of each securities with the beta of each securities. Okay, so your weight of KO, which is 14.29, and the beta of KO is 0.64, is gonna give us, you do the same thing for each of these security. So multiply weight with the beta and you're gonna get portfolio beta. So we got portfolio beta of 2.27. It's not a percentage, okay? Make sure you don't get confused. Beta is not a percentage. It's just a number. Beta is not a percentage. Okay? So, how to find the rate of return on the portfolio? Basically, you can just use that beta and everything else is same. Okay? Let's use CAPM equation, which is RI. In this case, we have RP, R sub P, which is portfolio return equals to risk-free return plus beta of the portfolio times RM minus RF. So only beta matters. Everything else is going to be same. So rate of return on any security or a portfolio is just the function of beta. So we got 2.27 beta, and we plug the beta in CAPM equation. We got 23.81% return. Okay, that's the portfolio return. Do you want to do longer way? Actually, what you can do is you can find required rate of return for each of these securities. just using CAPM. Okay, so find the rate of return on each of the security using CAPM. Once you find rate of return using CAPM, then multiply with the weight. Okay, once you multiply each of these required rate of return with respective weights, add them together, you're gonna get portfolio return. So here is basically weightage average in this case. Okay, so here I'm not using CAPM. First I use CAPM to estimate a required rate of return on each of these securities and multiply with beta. Okay, so this one is a little bit longer. This one is pretty straightforward. So you estimate portfolio beta and use that beta in CAPM equation to estimate portfolio beta. So this one is very short. Okay, this one here is a little bit longer. Still you get the same solution, same answer. So please practice this. All right. So now we have another example. Suppose market return is 14%, risk-free rate is 6%. Okay. So if you have $1 million fund portfolio, okay, what is your portfolio return? What is your portfolio beta? So basically, you're gonna find the weight first. You add all those investment amount. So each of the security, so add up them together, and then 150,000 divided by 1 million is 15%. So you find the weight of each of them. Okay. Once you find the weight of each of them, then you can compute portfolio beta. Portfolio beta is beta of each securities times weight of each securities. So you are putting 15% of your investment in stock A. So 15% times 1.5 beta plus 20% times 5.5 beta, and again beta is not a percentage. Okay, and then 25% times 1.25 plus 40% times 0.75. If you do all this math, you get 0.9375. That's the beta. That's a portfolio beta. Okay, so basically portfolio beta is the weightage average beta. Okay, once you find portfolio beta, just use CAPM equation and use the portfolio beta to get portfolio return. So this is required rate of return on this portfolio is 13.5%. Okay, if you want to use this longer version, that's fine. First of all, you have to estimate required rate of return for each securities using CAPM equation. Here you are not using CAPM beta, you are using individual securities beta. And then you can find weightage average, okay, of those returns to find portfolio return. So whichever way you want, please feel free to use. But I think this one is lot better, lot easier, because you have to do only two things here. All right, so when you plot beta and its required rate of return, you can create security market line. Okay, so security market line basically, it's gonna show you a risk return relationship. SML shows the relationship between risk and return. Here in this case we have risk is beta. Okay, so this one shows the relationship between systematic risk and a return on an asset, which is a part of the well diversified portfolio. So this is SML. So SML is basically CAPM equation. So here, for example, a risk-free rate, Okay, so this one is risk-free rate plus beta times market risk premium. Okay, here this one is market risk premium. So you multiply with market risk premium, you're gonna get this required rate of return on this security. Okay, so security market line, uh, there are factors they can change security market line. So if the inflation, if the investors raise the inflation expectation, so if there is expectation that inflation is going to go up, what happened to the security market line? So basically, inflation goes up means interest rate goes up. So that means risk-free return is going to go up. So this one is going to shift up. Okay. So change in inflation by 3%, cause change in risk-free return to 3%. So it's going to shift up security market line. So, but if there is a change in investors' risk aversion, okay, in that case, only market risk premium increases by 3%. So in this case, this SML does not shift, rather it becomes steeper. Okay. All right. So let's talk about market equilibrium. Let's consider these several securities here with different betas and then also expected return is given. So risk-free return is 4% and return on market portfolio is 10%. And beta is this each of these securities are given here. Okay, and then expected return of this security is also given here. So you have the information you need to compute required rate of return, and then you have expected return. When market is in equilibrium, the expected return should be equal to the required rate of return on the security. Okay, so basically you compare your expected return with required rate of return to find undervalue or overvalued securities. Okay, so using this information, so I use CAPM equation and estimate required rate of return for each of these securities. Okay, so if expected return equals to required rate of return on security, then that is the market equilibrium situation. So basically using CAPM equation, I estimate required rate of return on each of these securities and find the difference here. So expected return minus required rate of return. Okay, and basically if this expected return is equal to required rate of return, that is the fairly priced security. So all these securities, so in this case A, B, D, E, F, and H, I, J, these are the securities. They are fairly priced. Okay, but look at this security C. The required rate of return on this security C is 6.4%. Okay, this security has beta of 4. Okay, so if the beta is 4, so you should get 6.4% compensation for bearing that 4.4 beta. Okay, you should get 6.4, but your expected return is only 4%. Okay, so that means let's look here. Your required rate of return should be here. because your beta is here. So the fair price for that beta is 6.4%, but your expected return is less than 6%, which is 2% less than the required rate of return. Okay, in this case, this security, you pay too much price on this security. So paying too much price on this security means you are not getting. So paying too much price for this security, therefore this security is not giving you 6.4%, which is required rate of return. Therefore this is overvalued security. Okay, let's talk about the return and then go back to price. If you pay too much price, then your return is going to be smaller, right? So here in this security, you pay too much price, therefore the return is less than your required rate of return. In security G, actually your required rate of return is 11.2%. So this one here, but actually your expected return is more than your required rate of return. In that case, this security is undervalued. In other words, you pay too little. Okay, this stock is cheaper. Therefore, the expected return on this security is 14%. Actually, the fair price of this risk is 11.2%. Therefore, this is cheaper stock, undervalued stock. Okay, so this is how you're gonna be using CAPM SML equation to find undervalued, overvalued, or fairly priced securities. If you require rate of return and expected return, they are same. That means this is fairly priced security. If your expected return is less than your required rate of return, then that means it's overvalued security. So C is overvalued security. And D is actually you need only this percent, 11.2%, but the expected return is more than that. That means this stock is too cheap. Okay, so in market equilibrium, what happens is investors, they will know that this security is too expensive. Okay, so a lot of investors, they're gonna start sorting this security because they know that the price is gonna drop and then they can make return. Okay, therefore there is selling pressure, and there is once the selling pressure is there, what happens is the price of this stock gradually goes up. Oh, sorry, goes down because there is a too much selling pressure. The price of the security is gonna go down. That means gradually this stock is gonna be giving you the return, which is fair. Okay, so the return is gonna be going up. And in this case, this stock is too cheap, so there is a buying pressure. So a lot of people gonna buy this security. Okay, so what happens is the price goes up. Once the price goes up, then the return is gonna drop to required rate of return. Okay, this is very important. So please understand how it works. Use CAPM equation to find required rate of return. And if the rate of return, expected rate of return is less than required rate of return, then that means that security is undervalued. If required rate of return and expected return are same, then they are fairly priced securities. If expected return is higher than required rate of return, that is undervalued security. Okay, so you use this SML equation. So SML basically plots relationship between a beta and required rate of return. Okay, So this is about CAPM. And before we are done with this chapter, let's watch this small video clip and learn a little bit more about the CAPM. So does the CAPM works very well in practice? Let's watch this.
Does the CAPM work very well in practice? We know that the CAPM, or the capital asset pricing model, is an elegant model which describes the relationship between required returns and risk. And indeed, the basic premise of this chapter talks about the connection between risk and return. We start from a simple idea that investors like returns and they don't like risk. Therefore, in order to induce an investor to take on riskier investments, you have to offer them higher returns. Where the CAPM comes in, it tells us what type of risk is most relevant. It starts from the idea that diversified shareholders are able to get rid of some types of risk, but they're still left bearing market risk. Market risk is measured by beta. So we're left with a relationship that says that the required return of a stock depends critically on the stock's beta. Now, a reasonable thing to ask is this model any good? Does it work well in practice? I mean, we know for sure that the model is widely used, that corporations and investors use the CAPM to gauge and make important business decisions. So it is useful to step back and say, does this model work very well? Now, I think it's fair to say that when the model was first developed, some early tests were run, and most of the evidence was pretty positive. It suggested that higher beta stocks had higher returns, which led us to believe that the CAPM was working well. Unfortunately, some more recent tests have led us to kind of go back and question that. We see that the connection between beta and returns has become a lot weaker in recent years. Now, there's two ways to interpret this evidence. One view looks at it and says that the model's fine, it's still an elegant model that describes theoretically the connection between risk and return, but the problem's the data. We have a hard time getting good information regarding the risk-free rate, good information regarding the market risk premium, and good information regarding beta. And so the problem isn't the model, the problem is the inputs that go into the model and collecting the data. The other view steps back and says, no, there's still fundamental problems with the model itself. And that's led some researchers to try to develop more multi-beta or multi-factor models to try to expand upon the basic CAPM. It's important, though, for you as you leave this chapter to understand the basics, to understand that there's a positive relationship between risk and return, and that market risk is often important for diversified shareholders. As far as whether or not the CAPM works well in practice, I think it's fair to say that the glass is either half full or half empty, depending upon your perspective.
So with this short video clip, so it's a very good overview of CAPM. CAPM is basically uh, tells us that required rate of return on a security is function of beta. Beta measures market risk. In when people are holding, investors are holding well-diversified portfolio, beta is the right measure of risk because we can diversify unsystematic risk. So only thing left over is systematic risk. So you should get compensation for only systematic risk. That's the whole idea of CAPM. So with this, we conclude this chapter. And thank you for watching this lecture video, and see you in the next class. Thank you.